Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars. Today we are going to be diving into idle speed control on the Adaptronic Modular Series ECU, specifically the one fitted to our FD RX7 project car. I think idle speed control is one of those features that we really do want on a street driven car. It's one of those things that kind of makes the difference between a properly tuned car that responds much like factory, basically regardless of the temperature or conditions, we can reach through the door, turn the key, and it will start and idle smoothly, and one that kind of really needs to be nursed by the driver for the first few minutes and the idle speeds all over the show. And really depends what you're actually doing as to how important that is to you, but we're going to see today what goes into that, what you'll need in terms of hardware, how the software works, and the tuning strategy behind it. Before we jump into that though, I just talk about a few things that are going on around HPA at the moment, and we are running another one of our giveaways, so we'll start off with that. So we'll head across to my laptop screen. I don't have the product on hand to show you, but we are giving away a FuelTech FT550 ECU. And these are pretty unique in my opinion because they're not just an ECU. As you can see, they're also a fairly fully featured dash display for the driver, also an integrated logger, and on top of that you also have touchscreen capability for some of the tuning functions. So that FT550 is going to come complete with a universal harness as well, so you'll be able to wire that into whatever project you're working on. It has a built-in map sensor on board as well. Just get rid of the phone call that's coming through, that's a bit awkward. And on top of that we are also including our suite of tuning courses so that you're going to know exactly what to do with that FT550 once you get it. So we'll head across to the page here. I'll get Luke to drop a link into the comments that you can follow after this webinar has aired to get yourself into the draw. Got 26 days left for this giveaway. It's the FuelTech FT550 plus our tuning course suite, so total price package there around about $3,000 US. We will ship that to your door regardless whereabouts you are in the world, so if you're not in New Zealand, don't worry, you're not going to miss out. It's a great deal, so jump on that package, make sure we'll jump on that giveaway, make sure that you don't miss out. Right, so I think probably a few of you are wondering what has happened to our SR86, and for those who've been following us for a while, you will probably remember that we tried really hard to get the SR86 up and running for last year's endurance racing championships here. We got a little bit sidetracked with, or sidelined I should say, thanks to COVID with our 3U ZFE build that we were going through. Realized it wasn't going to be ready in time and decided to pull the pin and put in the SR20 VVL engine, turbocharged engine that we had for our 350Z, and we only had a fairly tight time frame to do that. For those who have followed, you probably remember it didn't really play the game for us. It was a bit of a disappointment considering the amount of blood, sweat and tears that everyone around the workshop poured into trying to get that up and running, and we decided to just basically take a step back and basically focus on getting everything finished properly. That also coincided with a lot of course material release, which we also had to focus on. So obviously the course material is pretty important to us. That gives us material to send out to you guys, and that's obviously of course how we end up funding everything as well. So without that we weren't going to go too far with our SR86, but it has been worked on since you last saw it, and it's going back together for the final time at the moment. So I'll just jump across to my laptop screen. Jimmy, our fabricator, has been pretty hard at work on all of the hot parts as well as the intercooling plumbing, and essentially a lot of the work really needed to be redone, which is a bit unfortunate just the way everything worked out. But he's actually built this heat shielding, which we can see around the exhaust manifold. Understandably, turbocharged engines, the exhaust manifold and hot side components do get incredibly hot. We did have some basic heat shielding developed for it, but given the opportunity to redo this and spend a little bit bit more time, Jimmy got involved, and in particular, you can sort of see here, he has come up with a mounting system that uses safety wire here just to make sure that nothing's going to come undone. As part of this, we have also switched to a Tile Sport stainless V-band exhaust housing. So the eagle-eyed among you may see we've got a nice fresh weld in there for the new V-band. Interestingly, the Tile Sport housings don't share the same V-band configuration as the Garrett GTX 30 series turbine, which is a little frustrating, but it is what it is. Also, Jimmy's remade the exhaust front pipe and wastegate dump. They were getting a little bit too close to a few components for our liking, so with the ability to just remake some of these components and get them absolutely how we wanted them, we took that opportunity. You can also see in here the exhaust gas temperature sensors that would have saved us from one of our engine mishaps that we had very early on in testing. So we got those in there in the end, unfortunately a little bit too late, but I guess better late than never. Also a little bit hard to see, but we do have individual cylinder lambda sensors. You can only see one of those there, so that's an LSU 4.9 lambda sensor. It's a little bit tricky when you are running lambda sensors pre-turbocharger though. In particular, they are very sensitive to exhaust back pressure. With a turbocharged system, we're going to end up with quite high back pressure pre-turbocharger. It's not uncommon to see the exhaust back pressure exceed maybe double the boost pressure, and that will play havoc with the readings of the sensor. It's not actually the end of the world. We can compensate for this, and if we look here, we've actually got a port here for an exhaust back pressure sensor. This is incorporated into the Link Lambda CAN unit as a back pressure input. It's a bit of a long-winded way it goes. The Link CAN Lambda or Lambda to CAN units, CAN Lambda, that's the one. There's only 4 wires to these. They've got power, earth, and they've got CAN high and CAN low. So we can't actually fit the exhaust back pressure sensor directly into it. Instead, our exhaust back pressure sensor goes to our Motec dash, sorry, not our Motec dash, our Motec M150 ECU, and then that data is sent out to our dash, where it is then resent out via a CAN message to the Link CAN Lambda module. So long-winded way of getting it, but that's how we get that data, and it can only be received via the CAN bus. Sounds difficult, but when you understand how to program that, it's really not that tricky. Probably a good time to shout out if you do want to learn a little bit more about CAN. Our new CAN Decoded course presented by Zach, our wiring tutor, is available. You can check that out at hpacademy.com/courses. We'll teach you how CAN works, as well as how to make up CAN messages, how to decode CAN messages as well. So that gives us, or should give us, pretty accurate data, but the reality is when it comes to individual cylinder lambda sensors, I generally don't look too deep at the specific number that's coming off that sensor. Instead, we've still got another sensor which we can see here in the exhaust front pipe post turbocharger. That's not to say it's going to be immune to any back pressure, but generally a lot less back pressure there. So we use that sensor for the overall fuel tuning, and we use the individual lambda sensors for cylinder to cylinder trimming. So on that basis, it doesn't really matter if they're reading accurate lambda. They could be reading fluffy unicorns. I just don't care, as long as I've got the same number of fluffy unicorns on each cylinder. In hindsight, maybe not the best example, but hopefully you get the gist there. So that's all going together. We're hoping to have it back up and running, because I am in the middle of filming our cam control tuning course, which covers both continuously variable cam control systems as well as switch cam systems, which our Nissan VVL cylinder head includes. That'll work for Honda VTEC or Nissan NVCS as well. The other aspect is we do have vernier adjustable cam gears on that cylinder head, or on the cams. So the cam control course will teach you how to tune vernier adjustable cam gears as well. Moving on, another aspect that we were not confident was going to work for an endurance race was the cooling system. So this is a shot of the front of the car here. We've got basically matching oil coolers on both sides. So this is the right hand front corner of the car, and we've got a mirror image of this on the other side. This one here, That's weird. This one here is, I believe, for our transmission oil cooler. We've actually got the pump for that sitting here. Again, pretty important on an endurance car, something you wouldn't worry about for a street car or a sprint car, but we to keep up with TTI's recommendations, we need to keep the oil temperature in the transmission below about 120 degrees C. So decent sized oil cooler there. The other side has our engine oil cooler, but of course the cooler is only one aspect of it. It's getting the airflow to and then from the oil cooler that is just as important. Previously we were a little bit shrouded by the front bar and the airflow was a little bit sort of below what we wanted. So Jimmy, our fabricator, has come up with this pretty much a work of art that takes up all of the available room. This bolts to that structure. The back section here bolts to the oil cooler, and basically this is going to be the opening that we have filling up all of the available space in the front bumper to get airflow to that oil cooler. Getting the airflow away from the oil cooler though just as important. And while most people would just vent this into the wheel well, that's actually a high pressure area, so it doesn't really induce good airflow through the core. So what we've actually got is a system where there's another duct on the back of it made out of alloy just like this that ducts the air out towards the edge of the front bumper, but it's quite an intricated sort of design to get between that alloy fabricated component and the front bumper, and that's where Brandon's been busy with our Creality 3D printer. So he's made this design. It's probably a little bit hard to see, but he's designed this in Fusion 360 and then printed it out. So this took a couple of iterations just because, as you can see, there's quite a lot of variation between the angles. This particular face here, which also mounts to the front bumper, is sort of contoured to the front bumper. So it's a little tricky to get it done, but it all fits quite nicely now. So looking forward to getting that back on the car, and hopefully we'll be able to get out to the track and test within the next few weeks. And we might even update on our YouTube channel. We've still got a long time before we've got any actual racing coming up, but we really want the car properly shaken down so that we're confident that when we do hit the track, the next time everything is going to work and we're not going to end up with any more headaches. Because let's be honest, we've probably had our fair share of headaches with that car for life. Talking about 8.6s, our other 8.6 is also getting some work, which I don't think I've actually got a photo of, which is weird. Okay, we have been having some fuel system issues with our RaceCraft 8.6, which runs the turbocharged FA20 engine. So in order to get on top of that, we finally bit the bullet and we have fitted a surge tank. I won't talk too much about it because I don't have the photo to show you, and probably won't make too much sense without the photo, but hopefully we'll have that back out on track, shake that down and make sure that fuel surge is a thing of the past. Certainly not something you really want in a race car. Now, I got an interesting little piece of motorsport memorabilia back over Christmas, which is this little guy here. This is a Pankel Conrod out of a Red Bull F1 engine, and in fact it's got this little piece of information that comes with it. So this one is actually from a Cosworth, or TJ Cosworth V10 that powered the RB1 Redbull chassis that was driven by David Coulthard and Klein during the 2005 F1 season. I just grabbed it because I'm a bit of a car nerd at heart, and really wanted something that was a genuine F1 component. Also, and it's obviously of interest as well, we hear a lot about F1 engine technology, but unfortunately we don't get to witness too much of it firsthand, certainly not until it's well past its use by date and the technology is considered basically irrelevant. So 2005 model year, obviously with the hybrid generation now, there's really not a lot of relevance to this, but interesting nonetheless, just the sheer size. And to give you a better idea of that, I have an Exhibit A here, which is probably a little bit more sort of what we'd be used to seeing. So the other example here is a H-beam K1 Technologies connecting rod from a Nissan SR20. So the sheer size is pretty impressive. This little guy weighs about 210 grams as well, versus our SR20 rod I think was about 400. Not a lot of other information we can really gain from this. the center to center length is around about 105 millimeters, as best I could quickly measure it up. And one of the things that we would never really get privy to the information on is aspects such as the rod to stroke ratio for an F1 engine. Safe to say that the rod to stroke ratio would be probably well above 2 to 1, given the RPM limits that these engines run to. But yeah, again, pretty interesting little piece of trivia. And I think off the top of my head, it was around about $200 US, which I didn't consider to be a huge outlay. Probably inevitably going to get asked where I got that from, and I think off the top of my head the company is called GP Box. They've actually got a huge amount of memorabilia from various F1 generation cars, so if you're interested in grabbing your own piece of F1 history, that would be worth checking out. Which segues nicely into another thing that is worth checking out. Head over to my laptop screen again. That is the fact that we now have a podcast, which is HP Tech Torque. This is something we've been asked about for a long time. It's been suggested over and over again that we start our own podcast, so we've done exactly that. So if you are interested, you can head to hpatechtorque.com, or basically you're going to find that anywhere you probably already consume podcasts anyway. So get involved and make sure you subscribe. We'd love it if you could give us a rating and a review on that as well. We'd really appreciate that. It's going to help us grow there, and over time as we grow, we're going to be able to get more guests on that podcast and basically bring you a lot more information. I want to just cover off quickly as well one of our video releases which came out just recently. I wasn't doing a webinar last week, so I'll just cover this, which is ITB Tuning, individual throttle body tuning. We actually had the opportunity just recently, or just before Christmas, to do a worked example on the M-Tron KV8 ECU on a Nissan R34 GTR, one of my favorite JDM vehicles. And the RB26 fitted to that is one of those unique situations where we have individual throttle bodies as well as twin turbochargers, and a lot of people don't really know how to deal with this. So I just want to quickly go over it. If you really want the in-depth detail, then by all means check out the YouTube video. But if we just head across to the M-Tune software here, I'll just quickly go over it. This actually isn't the file I used. I don't have that on this laptop, but it'll give you a bit of an idea anyway. So what we've got here is our main VE table. So this is essentially defining the fueling for the engine. Now the problem when we have individual throttle bodies is that manifold pressure is no longer a really good indication of engine load. So what we do here is, for individual throttle bodies, we use throttle position as the load axis. Interestingly, in the M-Tune software, this is still called efficiency calculation, but basically it is throttle position. So often it's referred to as alpha N. If you're tuning a naturally aspirated ITB combination, that's all you'd need to worry about for fueling. But with turbocharger, it gets a little bit trickier because we also need to adjust our air fuel ratio targets based on our manifold pressure. We don't want to be running the same fixed air fuel ratio from 100% throttle, 0 psi, all the way up to 20 or 30 psi. That's not going to work very well. Other intricacy here is if we look at the scaling on the load axis, we can see the break points, particularly from zero throttle, are quite closely spaced. We've got 0, 1, 2.5, 5, 10, 12.5, 15%. Now, this is important because the way airflow works through a throttle butterfly is we see quite a large increase in airflow across the first 10 or 15% of throttle opening. Conversely, when we get up to about 80% throttle, we really don't see very much variation in the airflow from 80 through to 100%. So we want to take that into account with our breakpoints to give us good resolution, particularly off idle and down in the idle and cruise areas. It's really, really important to have that additional resolution. All right, so that's our main fuel table or VE table there. But we also need to define, as I mentioned, different air fuel ratio targets based on our manifold pressure, or at least load. So let's click on our fuel table, fuel menus here, and what we're going to do is come down to lambda target tables and lambda table 1. So interestingly, this is a base file from Mtron, but interestingly they have actually used air mass final and grams per cylinder as the load axis for this table, which makes sense because really that's what we're trying to base our air fuel ratio targets on. Basically how much airflow there is going to the engine. Obviously, as we increase the boost pressure, we increase the airflow in grams per cylinder. But for most tuners, unless you come from an OE background, this is probably a little bit harder to get your head around. So we can easily reconfigure that load axis there to be simply manifold pressure. And then we can change our targets down in the cruise or idle areas. We've got nice lean mixtures. Up in the high boost areas, we can richen our mixture to suit whatever we're trying to achieve. Now, that all works pretty well for most of the situation. However, what we'll find is that once we really start pushing the turbochargers harder and they start becoming a bit of a choke point, our exhaust back pressure starts to increase, we're going to find that we're still at 100% throttle, and we start finding that at high RPM and high boost, our air fuel ratios will start tracking richer than our target table. Remember, that target table is not a closed loop table. The ECU doesn't necessarily end up making corrections if we aren't on that target. It's just a background fuel calculation that the ECU goes through to define what pulse width to deliver to get us to that target. So at very high boost and high RPM, we're going to find that we actually start drifting a bit richer than our target. So we've got two options of fixing that. If we go back to our main VE table, we would still be at 100% throttle. So we're still sort of basically always operating in this 100% throttle zone when we are at full throttle, irrespective of the boost. So understandably, if we start drifting a little bit rich at maybe 7,000 to 8,000 RPM, 100% throttle, we could remove VE from this area of the table. But then at our lower boost pressure, we're going to end up lean. So the way we can deal with this, if we go back to our fuel, we can also have a secondary load table. The secondary load table uses manifold pressure as the load axis, and then we can do a trim, which we can see here. It's only at high boost and high RPM, pulling a little bit of additional fuel out just to make sure that we still track our target. So that's the tricks there with individual throttle body boosted tuning. And if you're wondering how the ignition works, well, really no different there. If we go back to our ignition table here, this is just conventional. We're still using manifold absolute pressure as the load axis for that table. And when you set this up, it's actually incredibly easy to tune. It's not difficult like a lot of people think. We don't need to open our wastegates, take our wastegates off, or wire our wastegates open, which again I hear a lot of people talk about doing. Absolutely not necessary. Just tune the engine exactly as it's going to run. Start with our minimum boost pressure, the minimum we can get on the wastegate spring. We'll be at 100% throttle, get our air fuel ratio targets onto our, so they're tracking our target table. And once we've done that, we'll just start increasing the boost pressure, and you'll find that until we get to that choke point, everything's going to actually really nicely track our targets. It's very, very simple. Certainly nothing to be scared of. Righty, I'll just head back to my notes for a second here. And lastly for today, I just wanted to also cover off a Instagram that I put up a little bit earlier last week. And this is one I actually took a couple of years ago back at World Time Attack over in Eastern Creek, Sydney. And this is the PMQ Carbon EVO, probably one of the most immaculately prepared cars that runs there that I've seen. But the part of interest here was the arrangement that they've got on the exhaust manifold. So this sort of carries on from what I was talking about with the SR86 of our own. So what we can see there is we've got basically two sensor bosses per exhaust manifold runner. The one closest to the header flange there, we can see has an exhaust gas temperature sensor in it. So exhaust gas temperature is quite often used as a individual cylinder tuning input. So basically the premise there is that as the air fuel ratio leans out, the exhaust gas temperature increases. As we richen it, the exhaust gas temperature decreases. So we can use EGT as a bit of a guide to help us with equalizing the cylinder to cylinder variation. But there are other aspects that actually will affect the exhaust gas temperature. One of the big ones, and I personally believe they would have been suffering from that here, is how far from the exhaust valve the sensor is mounted. So if we look there at number 4 sensor, we compare that to number 3. Number 3 in particular, I mean, I haven't got a ruler in there. It's a bit hard hard to tell from a photo, but it looks very much like that. It'll be further away from the exhaust valve, which gives us a cooler reading. So these are the things we need to keep in mind when we are fitting the sensors to get the best possible chances of getting reliable results. But even then, other aspects such as coolant distribution through the cylinder head and the engine will also affect our exhaust gas temperature. So these other bungs that we can see here, these are for individual cylinder lambda sensors. The problem with this is that the lambda sensors don't tend to live a particularly long and healthy life when exposed to the high temperatures that we see pre-turbocharger on a high boost turbocharged engine. So in this case, I am assuming here, because I didn't tune this engine, but I would imagine what they've done is used individual cylinder lambda sensors solely when the engine's been on the dyno. That'll allow the tuner then to sort of calibrate what sort of variation in EGT they can expect when the lambda is actually consistent across all 4 cylinders. They can remove the sensors there and then rely on the EGT sensors, which tend to be a little bit more reliable during high boost, high RPM, high temperature operation. They can rely on those sensors for monitoring what the engine's actually doing out on the track. So kind of the best of both worlds without ending up breaking your bank account. We may find that some tuning shops actually offer the option to use individual cylinder sensors while the car's on the dyno that the actual shop owns. Obviously, every dyno shop's different, but that's something you could discuss with your tuner. Alright, we'll just finish off just by reminding you we've got the FuelTech FT550 giveaway coupled up with our suite of engine tuning courses, $3,000 worth of value. We'll ship that to your door regardless where you are in the world. 26 days left to get your name into the draw, so head across to the sign up page there. Again, I'll get Luke to drop a link into the comments that you can follow to get involved, and there are some other tasks that you can also complete that will give you some more entries into the draw, so good luck with that. Alright, give me a few moments here and we'll get started with today's lesson.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.